Hi guys, today we're looking at piecewise functions and evaluating them specifically. So we say that piecewise functions, this is going to be a function with two or more, yikes, two or more, and this should be plural, graphs over different restricted domains. Okay, so we'll have, there will be constraints on the domains. To start out, before we end up graphing, we're going to be evaluating. And each of these piecewise is going to have function rules compared to the restrictions, okay? So think of this is like category 1 or category 2. Number 1 here is asking for us to evaluate when x equals -4. That's going to fall into category 1. So I'm going to use category 1 rule, which is 2x minus 1. Let's say g of x equals. So I'm evaluating g at -4 to be 2 times -4 minus 1, which is -8 minus 1, or -9. So there's my outcome here. Okay. For g of 5, that's falling into category 2. So I'm going to use the 3x plus 1 rule. Again, we're inputting 5. So we're saying g of 5 equals 3 times 5 plus 1, which is 15, plus 1, which is 16. And then when x equals 1 precisely, that's category 1, which is my rule 2x minus 1. So g of 1 is 2 times 1 minus 1. 2 minus 1 is 1. There we have it. Okay, then these can get a little more complex. So again, we have our function rules versus the, what we'll call restrictions. And again, let's call these groups 1, 2, and 3. Okay, so when x is equal to 0, that's falling into category 2 because it's between -2 and 1. So I'm going to use the rule x plus 1, which is just, so if I'm evaluating f at 0, 0 plus 1, which is 1. When x is -8, that's falling into category 1. So f at -8 is -3/2 times -8 minus 1. That would be 24 over 2, which is 12 minus 1, which is 11. F at -2 is going to be falling into category 2. So let's change our colors here. So we're saying f of x equals x plus 1. F of -2 then is -2 plus 1, which is -1. And then for f of 10, that's falling into category 3. So f at 10 equals 3 times 10 squared, which is 3 times 100, which is 300. And there we have our evaluations there. Okay, now getting into graphing, okay? Because it's one thing to just evaluate, it's another to produce a graph. So first step, we want to write each piece of the function in a, that's really actually strange. I don't really like this. Let's omit the steps, guys, because we just have to look at the process, okay? So we're going to first explore the rule, what we're calling the rule, and then the restriction, okay? So you want to imagine, and then they're about having us evaluate one. But we're going to have a restriction that will cut. But first off, let's graph. So my slope here is 2. My b is -1. So beginning at -1, up 2, right 1, up 2, right 1, up 2, right 1, or down 2, left 1. So this would be my graph, but I'm truncating it. I'm cutting it at 1. Specifically, I want everything that's to the left because I want x less than or equal to -1. So I'm going to have a closed circle, and it's going to be going to the left here. Okay. F at -2 is just an evaluation. So this is 2 times -2 minus 1. -4 minus 1 is -5. And then we can throw out the excess. Okay. Next one, again, we have our rule and our restriction. Okay, my m here is 1/2. B is -5. So we're plotting at 1, 2, 3, 4, 5. up 1, right 2, up 1, right 2, and so forth. Up 1, right 2 is going to be like way over here. But we want to cut it at 0. And as a matter of fact, they want everything that's greater than or equal to 0. So it's going to be closed circle right on this line and everything to the right. And to evaluate, f at 4 is just a half of 4 minus 5. That's 2 minus 5, which is -3. Cool, that's it. Next one, we have our rule and our restriction. Okay, here I'm seeing an m of -1, b of 2. So I can plot down 1, right 1, down 1, right 1, continue that pattern on. Okay, but I'm going to truncate it at or between -3, 1, 2, 3. So right here and right here. So I want it right between these borders. I would be open circle because of my inequality sign, closed, and it's just going to be this little dumbbell, this little snippet in between. And then to evaluate f at -3, this actually I cannot find because my restriction says that x has to be greater than -3. Okay, next one, we have our rule saying that my slope is 4, b is -3, so down 3, up 4, right 1, up 1, 2, 3, 4, right 1. I'm cutting at 0, and I want to be x greater than 0. So open circle to the right. And then g at 1, which would be 4 times 1 minus 3, that's 1. Okay. Next one, we have a slope here, -3/2, b, -1. So beginning here, down 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. Cutting at -2. And we want everything less than, so we want it to the left. Also, it's going to be open to the left because of the inequality sign. And then f at -4 is just going to be -3/2 of -4 minus 1. So that would be 12 over 2, which is 6 minus 1, which is 5. The next one here, we have an m of -1/3. B is 5. So 1, 2, 3, 4, 5. Down 1, 1, 2, 3. Down 1, 2, 3. Be like over here. I'm cutting between 1 and 5. 2, 3, 4, 5. So it's just a tiny snippet. It's going to be closed on both boundaries. So like closed here and closed here. And we're just kind of approximating and connecting the two. Erasing the excess. F at 3 then is going to be -1/3 of 3 plus 5. That's -1 plus 5, which is 4. And there we have it, guys.